Yes. Is everybody with Layla on that? Edwin, do you know what question she answered? Okay, the question was, first of all, what is this answer equal to? What is this equal to? Michelle? 7. Everybody get that? You just plug it in, so you get 4 plus 4 minus 1, which is equal to 7. And then my next question was, what box tells you you can do that? And Layla already answered that question. That's theorem 1.3. Okay, is everybody all right on that? Is everybody okay? Okay, next one. Sorry? Okay, Cindy's saying 7. Is everybody with her on that? Okay, what box? 1.3 again, but not for polynomial. It'll be for, nice, good job, for rational function. Okay, good job. Is everybody all right there? Feel like you're working with me here? The boxes? Okay. All right, next one. Does everybody know what function composition is? Does anybody want me to review that? Anybody want me to? Don't be shy, okay? You want me to review it? I'll do it in 30 seconds. Do it? Yeah. Okay. So let's say you've got a function f that looks like this. And you've got g of x, let's say it looks like that. And if I do this, then this is function composition. Remember fog? Okay, fog, that's function composition. You really want to rewrite this as this, because then what happens is the problem becomes a plug it in, plug it in. Okay, it becomes very easy then. So if you put it in this notation, the first thing you want to do is take this and shove it in here. So then it becomes f of x squared. Okay, then what do you do, Lucy? Nice, good job. You take this and you put it in here. And you get x squared plus 1. Okay, so that's function composition. Right. Now the problem that we have here is that you're given this function and I want to break it up into a composition like that. In other words, I want an inside function and an outside function. So the inside function is g of x. And the outside function is f of x. So spend a minute thinking about it, okay? And there's not one way of doing it. There can be many ways of doing this. But for this particular problem, one way is extremely obvious. Okay, it's very obvious. Got it, Laura? Well, first I want you to tell me what this is. What do you think the inside function should be? In other words, can you see that there are really two functions in here? Okay, Tatiana, what do you want g of x to be? Nice, good job, girl. And what do you want fx to be? Fantastic, good job. Is everybody okay on that? Because then this guy here becomes f of g of x. So you'll take this and you'll put it in here. So it becomes x squared plus 4. Then you will take this and shove it in here. Okay, so that is indeed the correct breakdown. Okay, so now what we're going to do is we're going to invoke table 1, theorem 1.5. We're going to invoke theorem 1.5. And it tells you to get this limit would be the same thing as limit. Oops, my bad. Be the same thing as f limit. So what we do is we move the limit inside now. make it the limit of g of x, which is x squared plus 4. So what does this give me inside? What does that give me? 8. Is everybody there? Okay. And then Jonathan, what does this give me? Here's f, okay? Here's f. There's f. So what are you going to do? Ryan, help out. Root 8, but will you write root 8? 2 root 2. Is everybody okay on that? So that root 8 comes in from the fact that you'll take this 8 and you'll shove it in there. Is everybody okay? Okay. Okay. But you understand the f of g of x part. The part that Tatiana was talking about, the inside part and then the square root part. The composition's okay. All right. Then what I'm doing is if you open your textbook to page 61 and read theorem 1.5, okay, what it does is it tells you, see how you've got the limit on the outside first? What they do is they pull the limit inside. You with me on that? You want me to prove theorem 1.5 to you?
Is it just I have to do it because it says so?
Because it's a theorem, right? Theorem is God-given. Am I allowed to use the word God in this class? Okay. Theorem has been given. It's given by the Greeks and by the Europeans. Good to use it. Okay? So everybody all right? Hank. Oh, Henry. Hank. No. Henry. Hank. No.
Henry sat here. That's Henry.
Cindy, you're Hank? I didn't know that. Henry, go.
Why don't we just plug it straight in?
Why don't we plug what in where?
Like, why don't we just put 2 into the square x squared?
Well, effectively, that's what happens. But it's based on the theorem that we have, right? Whether you plug it in straight off or whether... What I'm trying to do is you read all these boxes and I'm trying to make connections with these boxes with the examples that we've got. Otherwise, it's pointless reading those boxes because if I don't make the connections, then what? Okay? All right, is everybody okay on this? All right. Oh my God. Oh.